Hello everyone. In this video I'm going to talk about how to create random ID in Golang. A few days ago I created a video, the same concept in JavaScript, so you can use those packages in Node.js, TypeScript project, or even front-end application you have. And I was just thinking maybe I should do the same thing in Golang. So let's just dive in and find out how we can use it. Just before we go in there, I will also leave the link to the JavaScript version in the video if you have to look at them. But moving on, I will go and talk about three ways or three packages which is going to give us quite collision free or with the least probability of having collisions to create random IDs. And then we're going to go through all of them. We will see what is the pros and cons with each of them. To begin with, we're going to talk about NanoID, we're going to talk about UUID, and then we're also going to talk about KSUID. So let's dive in and just see all of them in practice. Then we're going to come back and talk about the rest of them. To begin with, I have created just a project. There's a Go module and everything, and then the module I created for them is just random ID. We're going to use random ID as a module, and then on each of them there is a project. So I will start with, for example, NanoID to begin with. In NanoID, if you go to the browser, basically this is the link to the GitHub repository. It's very easy to get it. I'll just zoom in a little bit. It's very easy to download. All you have to do is go get and then github.com/the username and then go NanoID. Once you import it, then we're going to use it. NanoID is very good and handy if you are going to generate a lot of random IDs, but at the same time you have control over the length and the characters, specific characters you want to use in your application. You will see what do I mean by that in a few seconds. And if you just go a little bit higher, so in the documentation, just going down a little bit in the documentation, you can see the collision calculator. So if you go to the collision calculator, this link, it will quickly give you, for example, an overview of how possible is that to have a collision. Means you're going to have duplicated ID. So if you're going to use all the small and capital letters in English, underscore, dash, and 0 to 9, so how many characters is that? And then let's assume the length of your character is 21 characters. And if you create 1000 IDs per hour, then it will take around something like this. So this number, 149, around 149 billion years to have 1% probability of having at least one collision. So this is a very big number. And also if you scroll down, if you just look at here, you can see where it's just giving some examples to understand the number here. So our human lifespan is around 79 years. And you can see how long will it really take to have that collision. Let's just drag this one a little bit lower. So I will talk about, like, for example, 10 characters. So let's say the length of our NanoID is 10 characters. How about now? With that characters we have here, it will take around 17 years. And let's also think we are creating a lot of IDs. And let's say we have a system that creates a lot of IDs. And we're talking about like 100 IDs per second. Then if you use 10 characters, this is the possibility. But the whole idea is really to just get it to the nice place and comfortable place for your service. So I would say, for example, if I want to just work on a system that has like 13 or 14 characters, you can see the difference between one character here. So 13 is around 25 years and 14 is around 200 years. So the whole idea is really to give you a peace of mind when you're going to create these IDs and they are random enough without any being worried about having a duplication. And I assume if you're going to just insert it in a database as a partition key, definitely your database is going to reject it and then you're going to generate one more ID. So it should be quite safe in that sense. Let's just create, for example, 100 IDs per second with 13 characters, and then it will take 25 years. And to be honest, in 25 years, I assume most of the services we write, we are going to rewrite them, or we're going to update them, do something with them. So these services going to be with different technologies or different languages, really depends. And this is going to give us quite like some time to think about these IDs. And also, if you're just curious about the Golang or packages in a go.dev, this is the link, and then you can just go through it. But let's stop talking about these theories and see it in practice. So talking about NanoID, so I will just uncomment the code I have in a main function, and then if I use NanoID, so I am going to close everything. There we go. So in NanoID, basically, well, in a main function, we're just calling NanoID generator, so nothing very fancy. In NanoID, we are going to import the package or the library, and then we're going to use it. So if we are going to create a standard NanoID, means just using really all the available alphabet with a length of 21, then that's how you're going to do it. So nanoid.standards and then 21 characters. If there is error, let's just panic. Otherwise, let's move on. Now that I have like this constructor, now I can create one. So this is the canonic ID. So I can call it as a function, and it will give me the NanoID. So as you can see, this canonic ID is just from this nanoid.standards. So we can give us that one. And then if I'm going to create, so this is this one, and if I'm going to use a custom alphabet or custom ASCII alphabet, that's how I'm going to do it. So I'm going to just only use digits or numbers here, 0 to 9, and then the length of 13 characters. So I have dictionary ID, and then I can just create one. So let's quickly go to terminal and see what do I mean by that. So go run main.go. There we go. So we have created one ID with a length of 21 characters. That's one. And then the first line, and then we are just you're creating another ID only with digits, and that would be the next one. The length is 13. So if I add A and B here, you will see for the ID2 from now on, we will have A, B, and the digits. Only these are the allowed characters. So if I just do again, go run main.go, you can see we have A, and we have B here again, and then moving on. It's very simple, it's very fast, performant. If you go to the documentation, you will see some comparison between UUID and NanoID, and then you can just do the comparison and see what you want. So there is a comparison here, there is a benchmark. If you scroll, I think there should be some benchmark here as well, and I already talked about the collision and the probability of the collisions. So I think using NanoID would be very safe. I am using this library and package in a few of the projects, and so far it's just very powerful and never had an issue. But you can just consider and just make this comparison at the end, and then find out what is the best and the right choice for your service or application you're just working on. Okay, I will move on to the next one. So I'm just going to go into close the NanoID. Moving on, we go to UUID. So with the UUID, it's just a famous one. So I'll go to the main and uncomment the UUID. Let's comment it out. And with the UUID, we have a little bit different format and pattern in a string. So if I open the UUID and close that one, that would be as simple as just importing the Google/UUID. So if you don't have it, just go and get it. So it's go get and then the link to the package. And then once you have it, you can create a UUID. If you're going to use it as this one, so UUID.new, then the return type would be a UUID type. As you can see, the type of ID is UUID.id. You can see there's a hover here. So, and then you can just do a bunch of things. So basically, if you want to see the ID, this is it. If you want to get the string version, if you want to get the time, the clock sequence, I don't know, if you really need all of this stuff, then you can do it. So you can get what version of UUID is that. So we're using, for example, version 4, just get the ID, get the URN, get the variant, and many of these things. Really depends if you want to use them. Out of like curiosity, you can just find out all of these things, but I think the very main and important ones are basically just a string, so you don't really need this, and maybe the version if you want to know what version we're using. We will come back to it in a few seconds and you can see them. Let me just comment out everything else. We will go back in a few seconds, and now if I just do go run main.go, you can see, so we are generating UUID, and then the string version is pretty much the same thing, and this is version 4. So, and if I want to comment out, well, uncomment the line of codes I have, you're really going to get some more information. Really, I don't know if you need them or not. So we have this timestamp, we have clock sequence, we have version, ID, we have URN equivalent, and then we have variant. But moving on, this is not really what we want. The only thing we want is just a string. So that's what you're going to use. And then if you are going to directly get the string version, so I think that's just made a mistake. So string. So then all you have to do is to say UUID.newString instead of new, which will give you a type of UUID, and then you can get the version, everything else. Then you can directly use the UUID.newString, and it's going to give you the string version. So the type of this one is, as you can see, string. The type of above in line 10 is UUID. Okay, so let's just print this one out and move to the next bit. So I'm going to clear and then run the main.go. You can see, so again, we are getting the string version. Exactly same things happen here. The only difference is first we are creating it, then we're gonna get the string version. The second one, we are creating the string just from the beginning, so there is no type or anything else. The next thing that I want to talk about is the parse. So let's just uncomment our code, and basically there is a UUID as a string. I just want to make sure if it is valid or not. So I'll just pass the UUID.parse, just pass the string, and then check if the new ID from this string is UUID or not. And if there is error, so we're really going to just print it out and return, or panic, whatever you want to do. And then if it is valid, we are going to get the version. I specifically created this one from version 1 just to show you, and then we can see the version as well, but for demonstration. But before going there, let's just see it in action. So the given string is valid and the version is version 1. And if I copy, for example, the one we created from version 4 and paste it here, okay, now we should get something different. So now it's version 4, because we just by default, when you use UUID.newString or UUID.new, it will give you version 4. So you have different versions, but you can use any of them. And then if it is not a valid one, so let's just say VV. So this is not valid because I think in UUID you can only use A to F, so you don't have really anything after F. So if there is something, then we can just parse it and validate it. So the way to do it is quite simple. Let's just do it now, and I am going to run it now, and it just says UUID is not valid, invalid UUID format. Okay, good. So the pattern is not correct. And next thing that I want to talk about is another package. So this package, UUID package, is from Google. We have another package which is pretty much going to give us the same functionalities. So I'm just calling it really other UUID generator for the sake of argument. But if you go here, good. So the second one is actually coming from GitHub, and then this user ID, username, and then go.UUID. And it's pretty much as simple as really using in previous one. So you are going to create a UUID. Now you have the possibility and options to create a version. So as you can see, so if you just go to UUID dot, and then I can just create UUID, sorry, I can just go new version 1, 2, 3, 4, 5 and everything else. So, but I mean, you have the options if you want to create one, but the common one that these days everyone use is version 4. So let's just use version 4, and we can just print it out, and then pretty much again the same thing. When we had parts here, now we have from string, so we are giving it a string, and then do the error handling and just check if it is, if we could parse the string to UUID. Okay, let's do that. I'm going to run this one. So we created UUID version 4, and then we could also successfully parse the given one. Really nothing very different. The only thing that I see is different if I go to the GitHub. So we have the, actually, okay, this is the UUID, which is coming from Google. As you can see, I'm going to zoom in a bit. So it's coming from the Google, and that has this amount of import, and the last published date, so it's 2021. The version is 1.3, and then if I go to GitHub, we have almost 4K stars. So that's the Google one, and if you go to the next one, it has a few more stars, so 4.7K stars. And really, I don't see much of different, but it's really up to you which one do you want to use. But again, if you look at the last commit was around 5 years ago. So I would probably go with the Google one, but both of them are there with the other one, which is this one. And the second example we were going through, you saw that we can use, for example, a different version if you want to create different UUID. Okay, moving on, I'm going to close this one. And also the next one, and maybe we don't need here. Let's also close the NanoID. Next one would be KSUID. So it's a sortable, unique ID. Pretty much same as UUID, but now you have ability to sort them, or just work with the just time, and then you can just do some comparison. What do I mean by that? You will see it in a few seconds. But before diving there, so that's how you're gonna get it. So go get, and then that's, I'll just zoom in a little bit. So go get, and then you can see that's the package URL, and then it will just some explanation about KSUID, and then very interesting read is the brief history of UUID. So you're going to see why well, let me just decline all of them. Okay, let's close. So what was the problem with UUID and history, and then what problems KSUID is going to solve. So I would just suggest give it a go, because it's very interesting article. And then why we should use it. So it's naturally ordered by generated time. So if you're doing, for example, some calculation, and if you want to see if the just list of IDs are sorted or not, when was created, and all of these things, you can have them with KSUID. The thing that you're not going to have with NanoID or UUID, but KSUID is going to give it to you. And then collision free, well, that's what they say. I think it's very close to none, or pretty much no collision, and then it's highly portable. Moving on, you can just see some examples and read about performance and everything else. But if you want to see the whole well, examples as a code, let's just see what do we have here. So I'm going to comment this one out, and now commenting out KSUID generator. So close this one, KSUID, and I will close this one as well. So I have a lot of things to talk about here. That's why you see quite a few lines. But to begin with, Let's comment out everything else. We'll come back to them in a few minutes. The first thing that we're going to do, we're going to import it in our import section. Okay, let's just comment this line as well. And then we're going to create a new one. Once we're going to create a new one, this KSUID example, the type is KSUID. Again, you can see we have a string, we have payload, we have time, we have timestamp. So what do I mean is this. So let's just clear the terminal, and then let's do go run main.go. Okay, that's the example. We are going to get the string version, so pretty much both are the same thing, so these two lines, but the very important part is here. So payload is going to give us the buffer, the time and timestamp is going to give us the time, which is right now when I created 28th of November. And the timestamp is the Unix timestamp that you're going to get from this string. So as you can see, you don't really need to have another field in your database or in your I don't know, records and objects that you're working on to just find out when was this ID or this record created in your database or anywhere you have really in a storage. So it's going to give you everything. And moving on, if you are going to get the previous or the next KSUID, then that would be very simple. So we created a KSUID example. I am going to just comment these ones because we don't really need them. And if you want to get the next one, just dot next and dot prev for previous one. So what do I mean is this one. So this is the, actually I just need to show the string. So now we can run it and find out. Okay, that's what we created, and this is the next one. So if you read this string, it's pretty much the same thing except the last one. So the previous to n was O. Sorry, that's the next one. After n we have O in alphabet, and before that we have M. So everything is the same. So if you want to see what would be the next generated ID or the previous generated ID, based on what we have now, we can just get it by next and prev. So it depends on the use case, you might be able to use it. The next thing is we are going to do some comparison. So if we have a few, okay, let me just uncomment the compare. So if you have a few KSUID, you want to see which one is bigger or smaller, basically you can compare them. What do I mean is this. If you, for example, we have a few IDs and we don't have created that or updated that to find out which one was created before, then KSUID will give it to will give this functionality to us. So let's just do it. So we are going to create a KSUID from a timestamp. So I'm creating one from yesterday. That's it. And the function or the method we're going to use from the KSUID is new random with time. So if you remember here, we are creating new, which is coming, it just created from now when we are creating this UID. But if you want to create a specific one for a specific time, then that's the one. So you're going to say KSUID.new random with time. This is yesterday. We are going to do some basically error handling here. Then we're going to create one for today. Actually, I don't need this one anymore. So let me just quickly moving around. Okay, so we're going to create one from today, and then we are going to create one for tomorrow, and we are going to print them out, and then just moving on. Okay, and then we're going to do some comparison. So we are going to compare yesterday with today, and then we're going to compare today with today, and we're going to compare today with tomorrow. Sorry, today with yesterday. So and then we are going to see the output. I'm going to just, okay, now it's easy to read. So here really we just created 3 KSUID from some time and timestamps, and then we're just comparing them. So let's see what do we get here. So this is the KSUIDs from yesterday, today, and tomorrow, and the KSUID from yesterday, when we're comparing yesterday and today, because yesterday, or the first one, is smaller than the second one, whatever is that, we're going to get -1. And if we compare today and today, so both of them are the same, it's down to seconds or milliseconds. So I'm just comparing the date, but they are exactly down to milliseconds. So we're going to get 0 if both of them are the same thing. And then the next one is if we have comparing today and yesterday. So today is bigger than yesterday, we're going to get 1. So that's how you're going to compare them. And it would be quite interesting or maybe handy if you're going to find out which record was created before or after the other one. So it's the comparison. And the next thing that I want to do is, so I am going to literally comment this bit, probably yes. And then I am going to do the sort functionality. So sorting is also very important. If you have array or slices of these KSUIDs, you can sort them out and just put them from, for example, I don't know, the oldest to the youngest, or the one which was created in the past to the most recent one. And the way to do it is quite simple. So as you remember, we created a few. So we created yesterday, today, and tomorrow one. Coming back to the sort, we just add them to array, and then we are checking if they are sorted. So if they are sorted or not, we're gonna just print it out, and we are using the method isSorted from KSUID. So KSUID is actually coming from the package itself. Okay, so we are saying if it is sorted, so we are saying if it is not sorted, then let's sort it. I am going to just put ... so it's easier to read. And then so we are going to sort it, and basically we're going to say check it again if it is sorted after this KSUID sort. And then the argument to the KSUID.sort is the list or the array which was we created. And then after that, we're just going to loop them and just check the time from that list. But if you look at the list here in line 46, so we put tomorrow, we put yesterday, and then we put today. And as you can see, this is not sorted. What is the expectation? Basically, the expectation is to put yesterday, and then we put today, then we would put tomorrow at the very end. And let's see it now. I will just go here. So this is the comparison, ignore it, the sort. Okay, is the list sorted? At the beginning it wasn't sorted, so we're coming to the if statement, and then we will sort it. And then the next question we have, next print we have is, now how about now? Is it sorted? Yes, it's true. And this is the fun bit. So now it is sorted, we're going through the loop, so with the range, and you can see yesterday 27th, today 28th, and tomorrow is 29th. So all of them are sorted now. The next thing that we want to do with KSUID, which is still fun as well, let me just comment out. Actually, I'm going to leave everything here. The next thing is to parse. So we have a KSUID string representative or representation, and then we are going to see if this is actually a valid KSUID. So we're going to use KSUID.parse here. So we have KSUID.parse, and then we pass the string. We want to see if it is valid or not, and then do some error handling, and then you're going to say if it is valid. If so, just let's get the KSUID from string. So the type is KSUID. The last one is to get the time from that KSUID. So let's just do it. Okay, so we're parsing it. Given a string is valid, and the KSUID is this one, and also the time stamp or the time when that KSUID, this KSUID was generated is here. So it's today, like probably an hour ago when I was testing it. So that would be pretty much handy. If I just remove, for example, these two characters, now we are expecting some errors because it shouldn't parse it because it's not a valid KSUID. Let's test it now. And if you just do it now, we will get an error. KSUID is not valid because valid encoded KSUID have 27 characters. So you can see the error handling as well. So with the parse, you can just parse it and find out. Okay, so based on all of these things, we just gone through 3 very powerful and interesting packages to get the random ID in just Golang. So KSUID, NanoID, and UUID. All of them have some pros and cons, and depends on your use case, you can use one of them. For example, sometimes you don't really want to give extra information to anyone who use the system about when was this ID or this ID was generated or created, because maybe that's just too much information. Or sometimes you need some sort of I would say flexibility just to sort them or to compare them. Then KSUID is very good. Or sometimes the length is very important, so you don't want to literally go through I don't know, 27 character, or UUID is a bit longer, so you don't want to do all of them. So you want to literally just work on 10 characters, 15 characters, or just a specific characters. Then that's the time to use NanoID. So now we are at the end of the video, and I would just like to mention that if you enjoy these kind of videos, or if you think there are some benefits, please do let me know. Share the videos, like, and don't forget to subscribe, because I'm going to put more videos in the channel with the same concept. I am writing a lot of codes, and I will try to share them with you as well. Thank you so much, and I'll see you next time. I think we are just at the end of this video, and I hope this video would just give you some food, some thoughts to just this package comparison in any languages. Basically, my main languages are Hi everyone, in this video I'm going to talk about the best way to generate random ID and random ID generator. Hello everyone, in this video I'm going to talk about